Sorry, guys, we're just taking photos. Don't mind us.
Yeah, sorry.
Welcome, everyone. I have to say that I'm painfully aware that this is the last session of not only today, but also the full conference, actually. So, but it's good to be here. My name is Marcus Johansson. I am a cloud custom engineer. I had the honor of working with that fellow down there, Binesh Ladd, and these two guys, Ryan Carey and Sam Bashton from LUSH Engineering, and also Claranet, the partner who did lots of the heavy lifting here.
Yes.
So we're going to, over the next 45 minutes or so, we're going to describe what we did at LUSH and sort of like how we deployed it and these kind of things. So let's move forward here a little bit. But before doing that, before handing over to Ryan, I just want to set the scene a little bit so you know what we sort of like went through. So it may seem like an easy task, but when Binesh approached me early November last year and saying that, hey guys, this really cool company, LUSH, they want to go Google and put their stuff on Google Cloud Platform. Marcus, can you help them? Can you support them? And I was like, yeah, that sounds cool. I mean, cool brand, cool company, cool guys, I'll do it. And then Binesh goes like, well, it's actually, kind of tight deadlines, so maybe can you do it in a month? And actually, this happens to be the peak trading period of the year. Is that still okay? And then later on, actually, everything is going to culminate into Boxing Day, the big Boxing Day yearly sale, so they're going to have an enormous amount of traffic going on. So is that still fine? That's still fine, right? And I was like, well, yeah, let's do it. Obviously, we're here today, so it did work out. I think it boils down, and you are at the right conference, Ryan.
Yeah.
So don't worry about it. I think that this is really a testament to really great technology, obviously, in GCP, but also it is really a testament to your team, Ryan.
Yep.
All of the great engineers, I see some of them here in the front rows, and also you guys, Sam, you guys at Claranet, with lots of good people as well. So I'm going to hand it over to Ryan to sort of
Excellent.
give you guys the background.
Thank you very much. So some of you may have been here yesterday for the keynote, so we're going to have to do a bit of refresh, just in case no one is aware of who we are. We've had some great comments over the years of whether we're a lingerie brand or whether we do cosmetics and other bits and pieces, which we do. So LUSH itself is a global cosmetics brand. We're UK-based, so we were founded around about 22 years ago now, down on the south coast in Poole. We're in we've got about over 1,000 shops globally. We're in 52 countries, and we employ around about 20,000 staff, at which proportion of that, around about sort of 60% or so, is retail. But since then, digital has kind of like been a big part of our business, and we're seeing it grow more and more, in which I'm sure a lot of companies are seeing these days. So we kind of went through this process of why moving. So a lot of people have asked why Google Cloud. We were kind of in this position where our previous supplier, we were coming up for contract renewal, and we wanted to make sure that we could future-proof our technology stack going forward. And that's something that we couldn't have with our current supplier. We faced black box, kind of closed solution. We didn't have any flexibility to access any of our server infrastructure. It was all kind of done in a way that they wanted to, and we had no input. We had kind of poor support. It was a support team based out in the States, so we were always on a time zone different as well, which made it very complex. Excessive costs. Obviously, they're adding a markup on top of basically a cloud solution providers already, and that billing model was very much 12 months up front. There wasn't kind of like the benefits of what we see from GCP, which was like per minute billing, or even we weren't benefiting from Amazon Web Services at the time on like per hour billing as well. And one of the biggest things, vendor locking, which we kind of spoke about as well at the keynote, is that's one thing which is very critical to us. We don't want to be tied into any specific one vendor. So why did we choose Google Cloud out of the available offerings there? One of them, as I was kind of mentioning, is around future-proofing the technology stack. We were doing a lot of work with the likes of Kubernetes, so Google Container Engine, and now also as well going forward looking at like Cloud Functions. Google's got a great offering there. They're always driving the products forward, so it gives us a great base to kind of move forward with our technology as well. It lines to our ethical approach. We do a lot of work with open source, so we give a lot back. Our recent sort of Drupal architecture, which a lot of our system runs on, we gave back a lot of modules, a lot of commits. As part of this process, also working with Clarinet, we gave back a lot of stuff to Terraform, and we kind of actively give back to the open source communities as well with the technologies that we use. Again, no vendor lock-in. Google promotes the fact it's an open cloud. That's kind of been proved with our technology stack now going forward. We've built it in an agnostic way so that we can move it to any provider that we want to. Fast network and robust backbone. We're able to leverage that from Google also as well. We've got great billing, so per minute, sustained use discounts. We also see savings through preemptible VM instances as well. So we've been able to leverage those on kind of like dev and staging environments. We spin them up and we can shut them down again. So we don't have to have full VM services running all the time. And also on top of that, we get brilliant support as well. So 9 times out of 10, we raise a ticket, we've got a response within a matter of minutes. So timescales. Obviously, a lot of people have heard like the 22 days. So it is 22 days for the actual physical migration piece itself. There was a few weeks of planning kind of in between and contract negotiations and all the fun stuff which you have to do when you move supplier. So ultimately, project kind of kicked off 11th of November. And then we kind of moved the tight, aggressive deadlines for contract signed by the end of that week. And then from there, it was literally getting the resources allocated, bringing the teams together. So to carry out this migration, I will stress there was only 7 or 8 of us in total, I think, and a combination across all partners. So it was a very close team that did pull this together. And then literally, yeah, from the 1st of December all the way through to the 22nd, it was literally full-on development work, bringing all of our infrastructure into code. That was one thing we didn't benefit from previously. So it really was an overhaul, full re-architecture. Due to the timescales, though, we were very much lift and shift. So it was a real tight timeline. And the guys loved it as well, so it was always great. But I'll pass over to Marcus now, who's going to kind of cover over some of the architectural bits.
Cool. And just to clarify, when you say brilliant support, that includes me, right?
Exactly, yeah.
Okay, very good.
Yeah.
Good to know. So, all right, architecture. So this is where you guys started. So this is basically a big or a chunk of the LUSH e-commerce website as it existed before moving it to GCP. So basically, in the sort of like the middle figure there, we have sort of like the UK site basically and the backend for the UK site. So in the middle there, you have a stock management layer, you have an order stock solution there in the back, you have an order stock archive there in the back. There's a couple of Solar instances powering both the stock archives and also the actual website itself. And there is a queue management system for use like internal communication, obviously backend communication to a warehouse and lots of other stuff. A couple of global services there to the left as well. And then generally speaking, the way you guys did scaling was essentially to take couple of those components in the middle figure and then just extending those out to other regions in their previous
Yeah, so it was a lot of vertical scaling on that. So each one of those instances is theoretically a Drupal installation. It has its own custom set of modules and functionality around it. And then we leverage kind of Drupal's multi-site capabilities for that for scaling. So as Marcus is mentioning, it's very much you could only vertically scale those, so it was replicating the same monolithic application across multiple new servers as well. So there was not much room for capacity changes or any fluctuation in that as well.
So cool. So yeah, I mean, a couple of reasons to sort of like change this and moving to something more like platform-oriented, container-oriented, serverless-oriented. Obviously, we had the timescale and the deadlines against us, so we couldn't really do that. So what we did instead was a traditional lift and shift. And in the Google Cloud world, that means going to compute engine. So that's our infrastructure as a service offering, where you have all the virtual machines, basically. But we would have been plain out stupid if we didn't make use of some of the managed services that the Google Cloud Platform provides. Specifically, I'm thinking about the Cloud SQL, so just a managed MySQL service at the time. These days, we also have PostgreSQL, but we're using MySQL here. Also, in terms of monitoring, so there's something called Google Stack Driver, just making monitoring across GCP very simple. In our case, we just deployed a monitoring agent to our virtual machines, and voila, there is built-in monitoring. And a big one here I want to call out, really, is our load balancing services. So as opposed to many other public vendors, they will just provide you with basically something similar to an application or just like a server basically running a load balancing software. So that's not the case with GCP. In GCP, load balancing is just provided as a service as part of a property, as part of our networking fabric basically. So it's just a property of how we do networking. So that means that we can instantly give you a load balancer that instantly scales out to millions of queries per second. So that's what we're using here as well. So we're obviously using many other components of the GCP stack to power LUSH, things like Google Cloud Storage, things like Cloud DNS, things like everything around Cloud IAM, so identity and access management, and so forth. But these are the current core services. So they look a little bit like this. So basically, this is what's deployed in one GCP region. So everything starts with a load balancer as a service. Behind that, we have Varnish, just acting as a HTTP cache, basically, for static, repetitive requests into the system. Behind those, we have a bunch of different workloads that we pulled from the other presentation there. So basically, we have the front-end service, we have the content repository, we have the actual order store, we have the SSO solution, these kind of things. So all of these are actually scaled independently, so they are put into a managed instance group, meaning that we can associate them with an autoscaler. So depending on CPU allocation, we will actually provision and spin up more virtual machines in each one of those groups. Behind that group, we also have a layer, a cache layer. So that's obviously in place there to just protect the actual persistence layer, so the cloud SQL layer. So memcache is actually not auto-scaled, but it's still put into a managed instance group because that means that we can auto-heal it. So if one of those instances, for whatever reason, will crash, then our auto-healer will just bring up a new instance and continue from where the other one was killed. Cloud SQL is just running in a standard active-passive setup. So it's just Cloud SQL second generation in a read replica setup. So basically, we ended up with one of these setups in 3 regions across the world. I think your previous provider had something like 5 regions?
Yeah, originally we had it across 5 data centers. What we were able to benefit from was Google's backbone network, where after doing some latency tests, we found that we were able to consolidate from 5 down to 3. So it really does show that the GCP platform is running on a great network.
I like that. Less hardware.
Less hardware, yeah. Well, it reduces costs also.
Oh, I like that even more. Cool. All right. So obviously, this may seem like a small task, but actually 3 locations, 3 regions across 9 zones. Initially, we ended up with 175 instances, and that was only before the autoscaler kicked in. And that also with 36 Cloud SQL second generation instances. And this is only for the production environment.
Yeah.
So LUSH is really, you guys are really running a big business here.
Yeah, so that's ultimately production. You've kind of got the same replications for development and staging also as well, but we're benefiting now from the preemptible machines as well. So we're able to literally spin up development environments and staging environments on the fly, see that feature which has been developed, and then once we're happy with it, we can roll it into production and literally shut those machines down also as well. So we run kind of scheduled tasks to make sure that that's closed down every evening. So it makes sure that we're not spending money on resources that we're not actually using as well. So it's a great cost saving as well.
So one of the really cool things here was really that, obviously, you guys were new to GCP when you started this. You learned everything during those 22 days. Couldn't have done it without you guys, Sam, from Clarinet.
Thank you.
So why don't you explain what you actually did?
Cool. OK, thank you, guys. So yeah, 22 days when Google came to us and said, oh, you know, there's this project. It sounds pretty interesting. The timescale sounds pretty tight. I said, yeah, timescale does sound pretty tight. But we love a challenge. You know, that's what's fun in this industry is when you have some pressure and you have some way to really show, you know, the benefit that you can bring. So I think this was a great project from that point of view. So yeah, we spent most of that 22 days on a Slack channel with Marcus from Google, with Ryan and the rest of Ryan's team working through those issues, making sure everything was working. We spent a couple of nights as well, a couple of very long nights migrating it, but you know, in the end, we got there. So what I want to talk about is the philosophy that we run actually all of our projects with, and this had to guide us a lot more because we had such a tight timescale. We knew there was very, very limited scope to do any rework here. There was very little we could do. LUSH had a great team, but they didn't have a huge amount of time. So we had to do as little as possible to get it into GCP, whilst also taking advantage of the features that they needed to migrate for. There's no point in just doing a pure lift and shift and creating the exact same problems, just in a different environment. So when we build any environment, in any cloud environment, we start with this basic philosophy, with this lovely artwork that our art team has drawn. So in the old world, where you have physical servers, and maybe even in the cloud world, if, to be frank, you're not doing it right, servers are pets. And you know, if they get sick, you nurse them back to health. You make them healthy again. And you give them lots of love and attention. It's a big deal if one of them isn't feeling so well. LUSH are obviously a very ethical company. So when I talk about the cattle approach for farming, what I mean is that we treat them like a large herd, and when one isn't feeling so well, we put them out to the pasture where they're very well cared for by some other people somewhere. I don't know. But yeah. So, part of our core philosophy related to that whole cattle versus pets thing is, okay, what is minimum viable cloud? What's the least amount of cloud that we are prepared to do? Because bear in mind, we didn't just build this infrastructure, we support it for LUSH on an ongoing basis. So we were going to be on the hook. If this thing went down, it was us that needed to sort out the problem. So we needed to make sure this was going to work very well on an ongoing basis. So these are our minimums to have a supportable infrastructure. So one thing that might sound strange, especially to someone who's used to a more traditional infrastructure, you have to be able to terminate any machine at any time, and it will self-heal. So that obviously requires a certain amount of automation, and that means that we can then take advantage of the higher order features like the auto-scaling that Ryan and Marcus have spoken about. Because once you have a machine that can fix itself, you can have a machine that can create new copies of itself pretty easily as well. The infrastructure has to be active in 2 zones. So in Google Cloud, we have this concept of zones, which are isolated sets of resources. And for resiliency, we don't want a DR site that sits somewhere else and that we fail over to. We want that to be active at all times. So we know at all times that failover process is going to work, and that we're distributing the traffic between the two so that we can ensure that the site continues to be operation, even in the event of zone failure. And to be frank, zone failure is pretty rare, but it makes sense to build it in that way. When you've already done the first step of any machine can self-heal, it's actually very easy to also make it active across multiple zones. Another thing which I'm going to talk about in a lot more depth in the next slide is infrastructure defined as code. But that, for us, that is the only way to work. A few people have said to me, well, isn't the Google Cloud Console pretty? Yes, it is, and you should never use it. The other thing we did, we use drop-in replacement services where they're available. So as Marcus mentioned, Cloud SQL, it didn't make sense to run our own MySQL servers when Google have a great service that essentially lets them do most of the hard work for us. Why wouldn't you use that? The other thing is automated deployments. We don't want to be the bottleneck for our customers. Ryan and his team have lots of improvements they're making all the time. And we want to give them a really solid way to test that they're working and a way to get them into production. So that's a hard requirement, non-negotiable. You have to have automated deployments as part of your infrastructure, and we build that in as part of everything we do. So we used a wonderful tool called Terraform, which is an open source tool. Obviously aligns very well with as LUSH have open source as their key values. For us, Terraform is brilliant because it's open source. And actually, when we talk about some of the problems we had, if Terraform hadn't been open source, I think we would have had significant difficulty making our 22-day deadline. As it was, we had the code. If things didn't work how we expected or features were missing, we could just go and add them. So let's talk a bit about what using Terraform even means and what I mean by infrastructure as code. So in the old days, when you were looking after servers, there was this thing called ops. And as an ops person, it's that pet model. You log into a server and you type some commands and you maybe edit some files and you make it do a thing because this is going to have a long life. You can do that. In the modern world, we don't do that. We use configuration management to manage the config on the servers, and we define the infrastructure, so all the Google Cloud resources through config files that are processed by Terraform, and Terraform spins up the infrastructure for us. So when I said, the Cloud Console is a pretty thing that you shouldn't use, you don't need to use it for anything. Terraform is doing all the work of building that infrastructure for you. And that's a large part of the reason we were able to do this migration in such a quick manner. because we kind of didn't. You know, a lot of people have said to me, did you really do it in 22 days? Kind of. So kind of as in there was a completely empty Google account at the start of the 22 days. But the reality is, anytime we go to a customer, we have a pre-built set of building block modules that we're building on top of. You know, it's a bit like Lego bricks. We fit those together, and we come up with a customer's infrastructure. And inevitably, there are always things that are specific to the customer, things that the customer does in one way that your expectations had been slightly different. But Terraform gives us flexibility to change those things where we need to, and to reuse generally about 80% of our standard building block templates to build any infrastructure. So that massively accelerates because you only have to do that last 20% of the work. And the great thing from the point of view of the engineers who work on this, that 20% is generally the more interesting bit. The dull stuff where, well, you know, I've got to spin up another load balancer instance, I've got to do this again. You don't need to worry about that. That's all standard. It's the interesting bit, it's the edge cases that you get to spend your time on. So by having these templates, what we could do is we could just build everything once, and then we can stamp out all the different copies we needed. So we needed different copies of the environments for dev, we need another copy for stage, and we need the production environment as well. And all we do is we say, okay, so we use variables for the machine types, because you probably don't want in development the full fat instance types. We run preemptible instances in dev and staging. We don't use preemptible in production. Preemptible instances, for those that don't know, Google give you a massive discount for these instances, but they also don't guarantee they'll actually be running. They essentially say, look, you know, it's best efforts. It definitely won't run for more than 24 hours. At the end of 24 hours, you'll get a new one. That's perfect for a dev environment. That means we have full testing, that the machines come back correctly and are working, you know, could be terminated at any point in production, and they're massively cheaper. You know, we saved LUSH significant sums of money every single month by using those preemptible instances. And that's just a variable in our templates. Should we be using preemptible VMs for this environment or not? All the rest of the template looks exactly the same. So we stamp out all those different copies, and then we've got multiple regions. So we stamp out even more copies. We stamp out copy for production in APAC, copy for production in EMEA, copy for dev in those regions as well. So actually, with comparatively small amount of work, and I say comparatively in terms of the actual output, we can build a really strong, reliable environment, and we can be certain that when we test stuff in dev and we test it again in staging, it's going to work in production because it's using the same templates. It is essentially the same environment, but you know, it's a safe playground for us to test things in. So there's roughly what, you know, one of the Terraform templates looks like. Gives you just a bit of an idea of, you know, what our guys were doing for those 22 days. They were essentially understanding what the infrastructure looked like and putting it into code. So, you know, Marcus said, look, this is the sort of scale we're talking about. So this wasn't, you know, just a couple of web boxes and a database. This was pretty serious infrastructure here. And it was less than 2,200 lines of Terraform code. If you've never done Terraform, I guess that doesn't mean anything to you. That sounds like maybe a lot, maybe a little. I think that's pretty efficient. There was a certain amount of repetition in there. I think certainly the clean code police could come and tidy things up a bit, because anytime you're under pressure, you're going to emphasize things that work over the most beautiful solution. But actually, it was really pretty clean anyway, because we were just reusing our building block templates, which have been written in that time, that weren't done under the pressure of that 22-day deadline. You know, most of those have been written months, sometimes even years before. So that's how we built the infrastructure. We used Terraform to do that. How did we configure the instances? So as Ryan mentioned, this infrastructure runs Drupal. Drupal's a PHP framework, and it's not It's not cloud native, I think you could say. There are lots of places where it expects config files, it expects values. I guess you could say it was written in an era where servers were pets, and some assumptions are baked in. So the way we dealt with that is we bake what we call ready meal images. We have a little microwave that makes them happen and be nice and warm at the point at which the machines get booted, and that microwave is Puppet. So Puppet, for those that don't know, configuration management, it gives you a declarative language to say, this is what the configuration on the machine should look like. So at boot time, these machines come up, they get their latest copy of the Puppet configuration management code, they run that, and then the machine's working. And obviously we have the cloud load balancers, which are checking the health of the machine. So as soon as the config's finished, the cloud load balancers say, yep, everything's good with that machine, let's start sending you some traffic. And that happens all the time. And the reason that happens all the time is because we have auto-scaling. So, across the course of a day, we are scaling up, we are scaling down constantly. And that's great. That's exactly how it should be, because the great thing about the cloud, or one of the many great things about the cloud, is we only have to pay for the resources we actually need for now. It used to be in days gone by, you would have to talk to your marketing team, get some estimates on what they thought the traffic was going to be. You'd probably double it, triple it, maybe more, depending on how optimistic you thought your marketing team were. And you would have to go and buy those servers, rack them, because the lead time to get new infrastructure online was, months probably. If you were really, really efficient, maybe it was days at absolute best. For us, spinning up an instance, it takes so little time that you almost don't notice it. In Google Cloud in particular, Google Cloud's very, very quick to bring up new machines. So we only want the amount of capacity we need for the traffic levels right now. So if it's a quiet time, we should run relatively few machines. And if it's busy, we should be running more. And we shouldn't have to think about that too much. We shouldn't have to plan, okay, well, 7 o'clock in the evening, that's quite busy there, and we should scale up. The autoscaler should do it for us. And Google apparently know quite a bit about making sure that things have appropriate capacity and capacity planning. So we attach an autoscaler to it, and it does its thing, and we didn't have to think too much about it, which is nice to think about. One of the things I really love about Google Cloud is that ability to say, actually, we just want to target this level of CPU utilization on the machine. So we don't have to start writing triggers that say, well, if it goes beyond this threshold, you should add this many machines. But then if it gets a bit higher than that, you need to add this many more machines. We just say, no, try and average about 65% CPU. It does the rest for us. That's a really nice feature, and that's a key difference, actually, between the other cloud platforms that we've been working with previously. So I said before, one of the really important things for us is making sure that our customers can get their code into production and that we're not a bottleneck for them. And the way we do that, we use another piece of open source software. You've probably seen a theme here, called Jenkins. So Jenkins is actually a CI tool. It does a number of automated tests on code check-in. And we also use that same tool, Jenkins, to deploy code into production. So the guys at LUSH will commit code into GitHub, and Jenkins will notice that change and automatically deploy it onto their dev environment, where their team can test it and find out, is it doing what we expected? And then when they're ready to put it into production, they commit it to another branch. It goes onto the staging environment. There are tests, both automatic and manual. They click another button. That's it, gets put onto the live servers. And the same build artifacts that got built at staging are exactly what's used in production. So we can be certain if it worked in stage, it's going to work in production, because the infrastructure was created from the same templates, the code is the same packages, and we're using the same Puppet manifest to configure the machines. So we can have a really great level of confidence that if it works in the test environment, it's going to work in production. And that frees up the developers to concentrate on developing and not trying to debug strange issues about, well, it worked on my machine, why isn't it working on the actual site? So something that was great for us, particularly given the hugely tight timescale that we had, is Stackdriver. So previously, for our centralized logging, we would use the Elk stack, Elasticsearch, Logstash, Kibana. Now, we're very big Elk fans, but it was quite pleasant on this occasion that all we needed to do was install a Stackdriver log agent, and all the logs got fed to Stackdriver, and we had everything we needed. We could go live. We had all the metrics that we needed to support this infrastructure, and we didn't really have to think about it very much. We had a small Puppet module that said, yeah, make sure this Stackdriver agent is running. That was it. The Stackdriver agent was baked into every EMEA, every machine. That was it. So was it all really easy? Well, no. As I mentioned, we had to pull 2 all-nighters to get this thing into production. There were lots and lots of long days for the team. We found some interesting things that we were able to fix. I think the hardest bit for us was the platform that LUSH were moving from. As Ryan said, it was a bit of a black box, and often we had to make assumptions about what that platform was probably doing that we couldn't really validate. That accounted for a lot of lost time in those 22 days where we'd assumed something, you'd test, actually, look, we've got different behavior here. It's because actually that assumption wasn't valid, going back. One of the things we love doing is contributing to open source. Actually, a lot of the people that come to work for us, that's a key reason they give for wanting to come and work with us, because we give them that opportunity to work on the open source projects that they're really passionate about. And that's also a reason why our team like working with Google Cloud so much. It's that open nature. So we had to improve the Terraform support for Cloud SQL 2nd generation. I think most of those changes are now in Terraform 0.9. I think there's still some PRs open. I think it was around the replication and read replicas within Cloud SQL 2nd generation that we needed to improve. But we were able to do that. That's the great thing about open source. As long as you've got a skillful enough team, you can fix these things. The worst bit about the locked-in platform that Ryan was in previously is that they were using MySQL. They were using an open source database, but there was no mechanism that we had available to us where we could use database replication. So that meant we had to do a dump of the database and restore it afterwards, and that meant multi-hour downtime. And for us, that's something we would work really hard to avoid. 9 times out of 10 you can, but the reality was that, especially given the tight timescales, it wasn't something we could do without. The good news is, now LUSH are in Google Cloud, that will literally never be required again. Google, their commitment to openness, there is a way to do that replication. We could get that data out quite easily and move it somewhere else. There's no need to, but it's nice to have that knowledge that you absolutely could. So, I spoke about auto-scaling before. The amount of money saved by moving to this infrastructure, I think, is pretty significant. That auto-scaler magic makes a huge difference. Switching to preemptible VMs, again, here's even more money we've saved. Google Cloud has a really nice feature called right-sizing recommendations. So you go into the lovely console, which I guess I'm now thinking maybe I was a bit hasty criticizing it earlier. And it will tell you the size of machine that you should be running versus the size of machine you're actually running. So if you've over-provisioned on memory, for example, it will tell you that. If you've under-provisioned on CPU, it will tell you that too. So if you need to scale up or you need to scale down vertically, it makes those recommendations. And that, overall, 40% saving is around about what LUSH saw. Actually, that's when we wrote these slides. I think we've saved you even more money since then. Month on month, we've been delivering significant savings, going through the infrastructure config, changing things, to get them to where they need to be, using right-sizing recommendations, changing the amount of reliability and high availability in some of the dev and test environments, and we've been able to save even more money on an ongoing basis. So everyone at Google talks about the global network. People might be a little bit sick of hearing about the Google global network because Google talk about it quite a lot, I think. I'm still just in awe of this thing. You know, there are literal cables going between continents. That's just, you know, it's still amazing. And it makes our life really easy as well. So in other cloud providers' platforms, we had to spend a lot of time working around the fact that regions are completely isolated. In Google Cloud, they're just one network. So we didn't have to worry about how we were going to get data securely from one region to another, how we were going to transmit these orders around the world. Google's network did it for us. It wasn't something we had to worry about. It would have been harder to hit that 22-day timeline in any other cloud provider where regions are completely isolated and we would have had to build VPNs or something like that between the different regions. That meant we could simplify the infrastructure. So we could simplify it because of the network, but also because of the network being so high performance that actually we needed less regions, which then made it cheaper. And yeah, auto scaling, I think, you know, that's the holy grail that LUSH were missing, really. So I'm going to hand back to Ryan now, and Ryan's going to tell you about where they're going with Google Cloud, because it's all very well getting there. You want to make the most of the platform once you're there.
Lovely. So as I was kind of mentioning beforehand, we're all about future-proofing our technology stack, and that was one of the main drivers over to Google Cloud Platform as well, because of the product, the offering it's providing, and where it's going also as well. So there's definitely some key aspects of which we've been able to benefit from straight away. Some of those are we're looking to move over a 12 to 18-month initiative now over to service-orientated architecture. So we're looking at microservices, breaking down our entire application through the entire LUSH business, and making sure that we're reusing code where possible rather than replicating the same users database here, the same users database there for different applications. We're looking at consolidating and bringing it all together. So that's one of the big initiatives that we can now do. Containerization of our application. So our existing application, like we were saying, it runs in Drupal. We want to look at how we can break that down as well and start utilizing the modern day tools which we use in our other applications like Docker, and basically being able to hook that up into our existing CI processes and CD process which Sam was going through. Our data warehouse as well. Now that we've got the abilities to utilize big data tools like BigQuery, Dataproc also as well from a Hadoop clustering perspective, but also as well Dataflow for Dataflow jobs. We've been able to look at new ways of improving our data warehouse and look to move that into the cloud also as well, rather than using more on-premise type solutions. On top of that, we want to start to benefit from cloud-native components as well. Some of you may be familiar with the likes of PubSub, again, messaging queues, but also as well Dataflow, which I was just mentioning. From that, we can look at bringing legacy systems into our cloud system as well, and it allows Dataflow to literally go from our legacy systems into our new applications until we're in a position where we can replace those as well. The future for us, we have big ambitions. So again, we're looking for a no-ops approach. Cloud Functions is coming soon. Some of you may have heard that over the last couple of days. This is literally the FAS, is like the next AAS type solution. So function as a service. We can really look at running specific sets of functions and only get charged for running that as and when it is required, rather than having to have a virtual machine up all the time to make sure that demand can be actioned. On the top of that as well, we're looking at around the machine learning and AI capabilities. How can we look to use that kind of technology in our day-to-day ways of working, or for a customer service? If you want to know where your delivery is, you have the ability to get an instant response through some sort of AI capabilities there as well, which we can train and make it self-aware from that as well. Not quite Skynet, but you know, aware to a degree. Again, speech, vision, and video APIs as well. We're very focused around our products, and that's very visually appealing as well. And we want to look at how we can harness things such as the Vision API. We have some great policies around being video first, also as well from our media studio and publishing side of the business. So we want to make sure that we can utilize that, but also as well speech as well. So how can we try and incorporate that in our day-to-day customer care and sort of customer service ways as well? So really, we've got some great plans. Google Cloud Platform is literally enabling us to do that. Again, open cloud. We're not locked in, so we can utilize this on any cloud provider that we want to, but we choose Google on the basis of what it's providing and where it's looking to go also as well. So yeah, thank you very much. We'll go to Q&A. OK, so we've got a little bit of time left, so we were going to go to Q&A. If anyone wants to throw any tricky questions at us for the last sort of 5 minutes. If there's not, great. I think we're... Oh,
we have
over
one
here.
there.
I know.
No.
Ah,
Yep,
Yeah,
there we are.
maybe now. Yes, hello. May I ask what e-commerce platform you are on, and if that affected the migration, whether you're on Magento or Demandware? And
Sure. So apart from, so LUSH is very much broken down into group-owned countries, and we also have partners as well. Our North American partner runs Demandware currently. That wasn't part of this migration. We did our group-owned countries. So we actually run Drupal Commerce out of our actual Drupal stack system. We helped write a lot of the current features in the Drupal 7 version of that as well. As for the difficulty around the migration, we were quite fortunate that all the work that we did around Drupal Commerce wasn't actually tied to our existing partner. So we were able pretty much to get a pretty solid lift and shift out into Google Cloud as well. So we were quite beneficial from that point of view. Hello.
Okay. Hi there. With hindsight, if there was one thing you would do differently,
Yep.
what would it be?
Have more time, I would say, was the biggest one. With that amount of time and the amount of coding going on and the amount of development work always going on, testing's like a big factor of it. And I think if we had more time, we probably could have got more testing in, specifically around load testing, and I think also as well, sort of running functional tests as well. We have a pretty solid suite of BHAT tests and automation, which we can run every time we do a build. But there's definitely more work we could have done around, I would say, load and performance testing also as well. That's not to say what we did deliver wasn't good enough. It was just, again, hindsight. It would be great to have a bit more time to benefit by utilizing that kind of testing methodologies.
How much development was taking place during all of this? Were you preparing new promotions and special code to support them in addition to the migration?
So like any business, current day-to-day development doesn't really stop. We were doing a lot of feature releases as well. We were building up to Boxing Day, which for us is a very high traffic period of time. So we're doing a lot of stabilizations. Oh, a fly. We're doing a lot of stabilizations into our application as well and developing new features ready for that period of time. So there was a lot of work still going on, so we were having to retrofit a lot of features into the migration process as well. But there was a period of time where we literally had to say, right, that's it. It's a feature freeze now. We can't continue to do any more. Otherwise, we're just going to keep replicating the same process of migration over and over again. I think it was probably about 2 weeks out that we started to say, right, code freeze is going in. We're not going to do any more.
Did you have to do quite a lot of organization change or process change in the way you were flowing the work through?
Ultimately, we're quite I would say we're quite a flexible company anyway. So when it comes to changes like this, we're expecting it. LUSH changes quite a lot. We work in a very agile way. So the processes of how we work, yes, we've had to change them slightly. I like to think they've got easier for us because we're not having to worry about so much of like cherry picking Git commands into code, packaging up releases, worrying about configuration, and then deploying all of that. From what Sam was saying, we've been able to automate that entire process. So a lot of the shift change is just, where do I find things these days? Is it I log into Google Cloud, or I need to go and look at the Terraform code if I want to make some alterations there instead around infrastructure? Otherwise, a lot of it is then also through configuration management on Puppet as well. So I would say we haven't had to make too many changes, and actually the team's embraced it pretty well because we knew nothing about GCP before we went ahead. This was a new thing which we went into, so we've been able to learn GCP and the ways that it works at the same time. So we really haven't had to do too much change.
Hi. As you move towards microservices architecture, has it made your application maintenance more complex?
Sorry, what was just the last part of that question?
Yeah, has it made your application maintenance, ongoing?
More complex.
Yeah.
Okay. I would say there's definitely a complexity coming into it. What we're trying to do is look at, when we architect microservices, how can we look at it that what we've already got in place, how can it complement what's already there? So with Drupal, we can use modules to build wrappers to interpret the APIs coming from the microservices. It's definitely making it a little bit easier from that point of view. But some of the complications come around Drupal taking on those services and how you might render some of that functionality to the front end of that. We don't want to necessarily be in a position where we're building a bit of functionality over here, building a microservice over here, when actually we just want to build the microservices and move to that side of the infrastructure. So I would say from a complexity point of view, it's not got too complex. It's mostly the microservices architecture itself, which is the complexity around service discovery, registry, and all those kind of fun things you have to deal with. But we're trying to focus more on building the new over here, leaving what's already here and just maintaining it. And then we'll look at how we can start to shift it over. So feeding those services into our existing infrastructure and architecture, and then making sure that we can make a smooth transition through that process. Is that it?
All right, looks like we're out of
We're
questions.
good. Yeah, lovely. Well, thank you very much, guys. Appreciate everyone coming, especially as the last session of the day.
Thank you.
Thank you.